Problem: a current sheet K bar is equal to 9 AY bar ampere per meter is located at Z equal to 0. The region 1, which is at Z less than 0, has mu R1 equal to 4, and region 2, which is at Z greater than 0, has mu R2 is 3. Given that equation of H bar 14.5 AX bar plus 8 AZ bar ampere per meter, then find H1 bar. Now here given this equation, so since boundary condition is related to Z axis, normal component is along the Z axis. We write here the problem was asked in university exam for 8 marks. We write here since boundary conditions is related to Z axis, the normal component is along Z axis. So Hn2 is equal to 8 ampere per meter, and Ht2 is 14.5 ampere per meter for current short. The boundary condition is, we write here, the boundary condition is this is equation 1. Now here AN12 bar is unit vector, normal to boundary, and it is from medium 1 to medium 2. Medium 1 to medium 2. So AN12 bar is equal to AZ bar. Therefore H1 bar minus H2 bar into AZ bar is equal to K bar, which is 9 AY. This is equation 2. Now according to boundary condition, it is equal to mu2 by mu1, that is equal to mu0 mu R2 by mu0 mu R1, that is equal to R2 by, so it is 3 by 4. Now it is equal to Hn2 equal to into 3 by 4. Now its value is 8 into 3 by 4, so it is 6 ampere per meter. Now H1 bar is equal to Ht1 bar Ax bar plus Az bar. This is equation 3. Now put equation 3 into equation 3 in equation 2. So we get Ht1 Ax bar plus 6 Az bar minus 14.5 Ax bar minus 8 Az bar into Az bar is equal to 9 Ay bar. So our equation is minus 14.5 ax bar is common, taken outside the bracket, minus 2az bar into this is az bar, it is 9ay bar. But we have ax bar cross az bar is equal to minus ay bar, cross product, and az bar cross az bar is equal to 0. So we can write ht1 minus 14.5 into minus ay bar is equal to 9ay bar. So we can write ht1 plus 14.5 is equal to 9. So ht1 is equal to it is minus ht1, so it is equal to 5.5 ampere per meter, and h1 bar is equal to ht1 bar plus hn1 bar, so it is 5.5 ax bar plus 6az bar. Now next problem. Asked in university for 5 marks. Find the components of magnetic field in Hertz which traversed from medium 1 to 2 where z is equal to 0. Plane is the interface having mu r1 2.5, mu r2 4, and the given equation is h bar is equal to minus 30 ax bar plus 50 ay bar plus 70 az bar mole per meter. Now this is the given equation. Now we write the normal component is along the z-axis. The normal component is along z-axis. So we can write hn1 bar is equal to 70 az bar and ht1 bar is equal to minus 30 ax bar plus 50 ay bar. Now according to boundary condition, what we can write, ht2 bar is equal to ht1 bar. So we can write ht2 bar is equal to minus 30 ax bar plus 50 ay bar. This is equation 1. Now for the normal component, right, for normal components, boundary condition is b and 2 is equal to b and 1. So we can write mu 0 mu r2 h and 2 is equal to mu 0 mu r1 h and 1. So h and 2 is equal to mu 0 get cancelled. It is mu r1 by mu r2 into h and 1. So it is 2.5 divided by 4 into 70 az. So its answer is h and 2 is equal to 43.75 az bar. Now from equation 1 and 2 gives the components of magnetic field. Next problem, based on problem on the magnetic scalar and vector potential. Now the given vector magnetic potential is A bar is equal to minus r square by 4 az bar vapor per meter. Then calculate total magnetic flux crossing the surface having values of phi is pi by 2 and r is in between 1 and 2. Z is in between 0 and 5. Now what is given? A bar is given. So given coordinates are in cylindrical coordinate system. So we write first given equation, it is r square by 4 az bar. This is equation 1. We write given coordinates are a cylindrical coordinate system. Cylindrical coordinate system. So first we calculate magnetic flux density. Magnetic flux density using equation B bar is equal to delta cross A bar in cylindrical coordinate system. Now we have B bar is equal to delta cross A bar. So it is 1 by R d by d phi of AZ minus dA phi by dZ. It is AR bar plus d by dZ of AR minus dA. So into A phi bar plus 1 by R into d by dR of R A phi minus it is A Z bar. This is equation 2. Now we can also use the equation of the curve in the determinant form. Either this or this equation, determinant form equation. Now the general equation of A bar in cylindrical coordinate system, it can be written as A bar is equal to AR small AR bar plus A phi bar plus AZ bar. This is equation 3. Now compare equation 1 and 3. We get AR is equal to 0. It is also 0 and it is minus R square by 4. So put these values right here. Put these values in equation 2. So equation 2 becomes B bar is equal to it is 1 by R so B bar is equal to 4 to R A phi bar. It is R by 2 A phi bar, equation 4. Now next, flux crossing the given surface. Now flux crossing given surface. Next is flux crossing the given surface. So it is B bar dot ds bar. This is equation 5. Since direction of B bar is A phi bar, the equation of ds bar in cylindrical coordinate system is ds bar is equal to dr dz A phi bar. So the equation is phi is equal to integration of r by 2 into a phi bar to dr dz a phi bar. So here we take the integration values. R goes from 1 to 2, z goes from 0 to 5, which is given in the problem. It is r by 2 dr dz. So we solve it and take integration separately. It is r by 2 dr and it is z goes from 0 to 5 dz. So it is 1 by 2 r square by 2 so it is 3.75. This is the answer. Next problem, an air-cooled solenoid having a diameter of 4 cm and a length of 60 cm is wound with 4000 turns. If current of 5 ampere flows in the solenoid, then calculate the inductance and the energy stored. Now first is part 1, that is inductance. Now what is given in the problem? Given that diameter D is 4 cm. So radius is 2 cm. In meter it is 2 into 10 raised to minus 2 meter. Now length is given 60 cm. So it is 0.6 meter. Turns 4000 turns. So N is 4000 turns. Also what is given? I, that is current is given 4 ampere. Now step 1. Step 1 is calculate magnetic field strength. Calculate magnetic field strength, that is H. So H is equal to Ni by L. It is 4000 into current is 5 divided by L is 0.6 meter. It is 33,000. Next, second step is step 2. Step 2 is calculate flux density. Calculate flux density, that is B. So B is equal to mu 0 mu r into H. Now what is mu r? It is 1 for air. So we write B is equal to mu 0 into H. Now mu 0 is, and what is H? 0.33. So its answer is 0.04188 Weber per meter square. Now the third step. Step 3. It is calculate phi. Calculate phi. So it is area A is equal to pi r square. So it is pi into 2 into 10 raised to minus 2 t square. So it is 1.2566 into 10 raised to minus 3 meter square. So phi is, it is B into A. So it is 0.04188 into 1.2566 into 10 raised to minus 3, which is equal to 5.2626 into 10 raised to minus 5 Weber. This is the answer. Next is calculate step 4. Next is step 4. Calculate capital L. So L is equal to N into, so what is N is 4000. So into 5.6 2626 into 10 raised to minus 5 by 5. So the answer of this is 0.042. And the second part of the problem is energy stored. So energy, calculate L, that is inductance. It is in Henry. Energy stored. So energy stored, E is equal to 1 by 2 Li square, that is equal to 1 by 2 into 0.042 into 5 square. It is 0.525 joules. The next problem, an air core coil 1.5 meter long, 8 cm in diameter, has 5000 turns. Then calculate inductance of the coil and magnetic energy stored when the current of 12 ampere passes through it. Now what is given in the problem? Length is given, it is 1.5 meter. Diameter is 8 centimeter, so it is 0.08 meter, and it's 5000. I is 12 ampere. Now the part 1 is inductance L. We have to calculate first inductance L. So for that, step 1, again calculate H. So H is equal to N by I by L. It is N is 5000 into I is 12 ampere, and it is length is 1.5 meter, so it is 40,000. Next is calculate S. Step 2, calculate S. So S is equal to 1 by mu 0 mu r A. But what is mu r? It is 1 for air. So what is area? It is pi r square. So pi into r is d by 2 square. So its value is 5.027 into 10 raised to minus 3 into meter square. Now we find S. S is equal to L is 1.5 divided by 4 pi into 10 raised to minus 7 into 5.027 into 10 raised to minus 3. So its answer is 237.45 into 10 raised to 6. Next is step 3. Step 3. Now what is step 3? Calculate inductance. Calculate inductance. Now inductance L is equal to N square by S. So it is 5000 square divided by 237.45 into 10 raised to 6. So it is 0.1053 Henry. Now next is part 2, second part of the problem, energy stored. So energy stored is 1 by 2 L into I square. 1 by 2 inductance is 0.1053 into 12 square. So it is 7.5816 joule. This is the energy stored when current of 12 ampere passes through it.